So starting off, for anyone who doesn't know, what is SQL? SQL is kind of like a coding language allowing us to interact with databases in a really convenient and efficient manner. We can perform tasks such as updating, retrieving, and doing calculations on large amounts of data. So then what is a database, you might ask? It's a pretty good question. You probably all know what a data set is. So it's just a collection of data in a file or in an Excel sheet or something like that. A database is just a large collection of those data sets. Typically, they're related in some sense. And so a data set will have like some key. For example, if you were like at a car dealership, you would want to keep track of the different cars as well as people who bought those cars. So those would be two different data sets, like the customers in the cars, and maybe a third for like orders. And then you could have keys that would relate one data set to the other. We'll get more on that in a second, but a database is really useful for almost all large scale corporations and data warehouses, because at a certain point, a collection of data sets is just not maintainable, as well as Excel has its own limitations. It's really great for what it's built for, but for massive amounts of data, Excel starts to fail. And so we use SQL. So this entire thing is kind of going to just be me talking about an aspect of SQL and then doing some examples with it. So if you want to follow along with me, you can go to this link. If you don't want to type that whole thing out, I think just online SQL, and it's like the second one to pop up. It's basically just a way to mess around in SQL. So I'll also give you all like a minute or two to type that in. I guess while people are typing it in, I can just kind of expand a little bit more. SQL, unlike a lot of other coding languages, has kind of just been the gold standard for like 40 years now. Like languages like Python and R, you could say, have like succeeded other ones, but they are always kind of creating new coding languages for certain tasks or better versions of older ones or updating older ones. But SQL, it has flavors, like certain, like there's Microsoft SQL and then there's like MySQL, but they're all based on the same language. And that language was invented by like some dude at IBM in like 1986, I think. It's kind of just been the gold standard since then. It's very intuitive, at least at first. It gets a little confusing later on. But once you go through all of this and practice it a few times, you'll never really not know SQL. It stands for structured query languages. Does anybody need another minute? Okay. So kind of like the base case of any SQL query is just select all from table. So I'll decompose what that means in a second. But if we just go to here and we just kind of run that query, we'll see this entire table that we grabbed. So we can see the available tables over here. This is just a data frame that they just have available for us to use. And so what we're doing is this star symbol just means all in SQL. So whenever you see that, just kind of assume it means everything, like all columns. It's grabbing everything in this table and printing it out. So it's the same. I can't think of a good analogy, but it's kind of like the base case. I'll go through kind of what those mean in a second. So then that right there gave us everything in a table. And for some cases, that's enough. If you're looking at small amounts of data and all you need is kind of a snapshot of what's in that table, just selecting everything isn't a bad start. But sometimes you want more granular views, or you want to filter that data in some sense. And that's kind of where SQL shines. You don't need to use SQL for small amounts of data. You can use Excel, but even still, SQL can still be helpful if you're trying to find very specific cases in that data or filter it in some ways. And so this here on the right is kind of the order of SQL. You don't have to know what any of those mean. I'm going to go through each of these one by one. But we saw at first, we started with our select. And so if we move forward, select is just a keyword to choose data that we want to query. And so when we start any SQL query, we start with the word select. Yeah, every SQL query needs to start with that, or at least contain it in some sense. And then we want to list the number of like the columns that we want to grab after that. And so in this first one, we did this star symbol, which would just grab all of these columns. But if we go back, we can select specific columns. So we go here, we can do like, if we just want this first column, a lot of spelling mistakes. this first column will just grab this. And so we could string that along with more columns. We could grab all columns. But this is, so for example, we could then do that, but then also get the age of each customer ID, and it'll print out these 2 columns. And so you can go deeper into what you can do with those columns. But for right now, you just take this select and you grab the columns from that specific table that you want. So we could also change the table that we want. We could go from like orders instead. And we could still grab those customer IDs that we see here this time instead. And so you can see that these 2 tables have the same name. That's because they're keys of a different table. And so in this case, customer ID is the primary key of customers. In this case, it's the foreign key. There's a lot of rules associated with those, but I'm not going to go into specifics. But essentially, you can use this foreign key in orders table to grab data from the customers table. And that's really kind of the purpose of SQL, is grabbing these relations between these tables and looking at, for example, the items that John Doe wanted to order. So moving forward, onto the next slide, we can then take that data that we grabbed, but filter out specific parts of it. And so in that first example, we grabbed like the customer IDs and the ages, but in some cases, you might not want to look at ages under a certain amount. For example, like some countries have like privacy laws for underage data, where you're not allowed to keep data under an individual who's under 18. And so we could, when running SQL, put that in there so we're not looking at sensitive data potentially in ways that we're not supposed to. So kind of going back to it, we have this customer ID. I'm going to go back, just grab all of the columns. Something I like to do when I'm writing SQL is just kind of separate these all into different lines and then put this semicolon at the end, because that indicates the end of our query. But it's kind of a pain to like have to jump in between. And if you have a very long query and it's all on one line, it gets very confusing. And this kind of helps to reaffirm this thing that we saw here of all of these in order. And when you have it like this in order, it helps you keep track of if you're making little mistakes, like if something is not where it's supposed to be. So we have this select all. If we were to run that again, we would get this whole table that we saw here. And so now say we wanted to look at, go back to customers. Say we wanted to look at customers in the United States. So we could do that. And then we say where and so running this, so it works in the same way that like a Boolean does. SQL works very intuitively like anything else. In this case, we use the strings, we use the equal to, but if we were to use like numbers, like maybe in a second we do age, we could also use less than, greater than. And so we just grabbed all the data. So we selected all the data from customers where a specific column equals a specific value. In this case, country equals the USA. And so we see we only got these 2. We could change it to like age. We could do greater than. And so now we're dealing with numbers. And so we're going to do like greater than 27, let's say. And if we run that, we get all the ages over 27, which would just be these 2 columns. Does anybody have any questions about kind of how that's structured? The one thing you need to make sure you like keep in mind is the order of these. For example, if we were to like put this above here, it would run some error because the query doesn't necessarily know then where you're grabbing from and whether or not age is a real thing. And so it needs to all be, and that might be a little annoying at first, but when it gets a bit more complicated and you're joining separate tables or you're filtering on something that you've already filtered, you really want to make sure it's in the right order. But it'll tell you when it's not going to throw weird values and you'll know pretty quickly. So we can also do comparators that are more, I'll do some of those as well. We can also do some different non-typical Boolean comparators like between, like, and in. And so we could do, if we were to do in, we could then give it a list of values. And so we could say, wait, we'll do country again. And this should work. Yeah, so now in this case, we're just checking where country is in a specific list of values. And so it only excluded this UAE because it's not in that list. I'm pretty sure we could do it the other way around and only get UAE. And so it kind of is pretty intuitive in that sense. You don't have to worry about specific things. So there's other ones like between and like. They're also intuitive. If you're curious, a good resource for this is W3 Schools SQL. It will just walk you through every basic thing in SQL from beginning to end. It has some ways to try it out as you go. We could also string these together. And so we had like country equals a certain thing, but we could also do country equals X and Y. So if we were to go back, it's the same idea as this in, but if we were working with maybe two different columns, we could say like age equals 22 and country equals UK. And so just like a Boolean, we can give this and in here and it'll grab the data where both of those conditions are true, which gives us just this one row. We could also do like or, and it'll get both. You might have noticed that I put all of these purple words in capitalized. You don't need to do that. They'll run if select is just the word select, but I think typically like a best practice for readability is to put them in uppercase. You don't really need to though. Some like IDEs will like auto put it in uppercase for you. This one's just not that smart. So from there, we have our data and we're able to grab specific columns from specific tables or all the columns from a table. But what if we want to look at that data in a more formatted way? We could use this order by to sort our data. And so we can see here, like we grabbed age. And if we want to look at maybe, I'll give you a different example. Say we want to look at like sales data from certain customers and we want to find whatever customer had or like the top 5 customers that produced the most sales in our company. We could use something like order by to order the total sale count and it'll give this. So if we were to look in here, if we were to go back, we'll get rid of all this because there's not a lot of data. We don't want to get rid of any. But order by would go after where, just FYI. We could order by age, for example, and then do ascending. So ascending and descending are the 2 keywords. Ascending will start with the smallest value and DESC, which for descending would start with the greatest value. And so it's not really super necessary in most cases. It's just a way to look at your data in ways that would be a bit more painful without it. But you're not using this unless you're showing your data. If you're trying to gather like statistics from this data, this doesn't really do you any good. But if you're trying to show somebody something specific, this is helpful. Does anybody have any questions so far? We could string just to kind of show. We could still, if we put where above, they'll still run. All of these are very modular. You don't need one in particular, except for these first 2. Like these first 2 keywords, you don't need any of the other ones, but you can use them all in tangent. They just have to be in the correct order. Okay, the next one is math. SQL can do a lot of various math. Some of the built-in ones that are kind of basics to start with are minimum, maximum, average, sum, and count. You can also use plus and minus to add together 2 columns, but you don't do that as much. But so minimum and maximum are pretty intuitive. Average and sum will just take the average of a specific column that you call, and same with sum, will take the sum of the specific column, and then count will count the number of rows in that column. You can expand on that a little bit more, so it counts in like unique rows versus not unique rows, but just kind of the basics are these 5. And so when you want to use these, you use them in this select. And so that's how I kind of said earlier, you can expand upon these. So if we want to take, well, actually, let's. So in this case, yeah, so we're looking, so when we run this, we grab this total age column and we find the smallest one, which is this column. It's not super deterministic on which way it's going to go. So if there's two, you don't necessarily know which one it's going to grab, which is why you want to kind of be careful what you do with this number, with this value right here. But so we're looking and we're grabbing that minimum age, and then we're grabbing the country in the row associated with that minimum age. And so that might not be kind of what you were looking for when you saw this select these two next to each other. But there is a way to then group by specific countries and find the minimum wage in each one. And we'll go into that, I think, in a second. But you could also then do like max age, which will once again grab USA, but with the maximum age of 31. If we get rid of this, we could find the average age of all of our customers, which is 25.6. The sum, which is 128, meaningless number. And then count will just grab the number of rows in this column, which should be 5. You don't really, I don't know if I've ever used this, but you can add columns together. They have to be of the same type. I don't think you can add strings. But for example, this would just add, it would create a column called this, and it would take each 31 plus 1 and then 22 plus 2 and add them all together to create a new column. There are use cases for this. I just haven't run across them. Does anybody have any questions? Yes. I'll get into that. Yeah, I'll get into that. We'll get to joins in a second, where you can join two tables, and then you could grab like the order ID of, say, the customer with the greatest age. But just for now, but we will get to joins. Any other questions? We shall see. Yes. You can also do modulo, which I didn't know. Okay. So next would be group by. So in that first case, we grab the country with the like greatest, or the country with the smallest age. Let's say we want to look at like the smallest age in each country. That might have seemed like what it was going to do in that query, but it didn't. And so you might be a little confused why not. Group by was, I guess, then added in to help solve that problem. And so group by would come after from, it would come after from and where, but before some of these other ones that we haven't gotten to yet, which would allow you to then group after you filter out certain data. But so if we were to do group by, thanks for that. Group by and so we can group by any column, just like we can select from any column. And so running this will grab each country and their smallest age. We could filter data before we did that. That's all right. Say we wanted to look at ages that are only greater than 23, and then find the smallest age of those. And so this would then do that. Is there any questions? Most of this is pretty intuitive. You just like, once you know that this exists, you just kind of do it. It's pretty hard to forget. And even if you do forget, you're probably aware that you now can do this in SQL. And if you just Google how to group columns in SQL or how to group by a value in SQL, you'll pretty quickly find it. Okay, so we could also rename columns from once we grab things. So if you saw before, like age plus customer ID, outputted kind of a weird column name. If you want to show that to people, it's not super helpful. And so if we just use as after any column name, we can just rename that column name to something else. You can also do that to your tables, which I'll explain why in a second. But for example, if we wanted to do this and then do like as min, if we run it, it'll now just output min as the column name. Not super challenging. Having is a little bit more confusing. It's basically where, but in any situation where you want to have math on a certain column. And so you can't do like where the average of a column is greater than 6. Although you can't do that in a where clause, but you can do that in a having clause. There's some reason for it. It's kind of annoying, and I always forget that this exists, and then I do this and it doesn't make any sense. But you just have to do it this way. These having does, it comes after group by and where, which is also an important thing. But so for example, if we had this query that we had above, we could then add in this having afterwards. And so now what we've done is we've done the same query we did before, where we were grouping countries and finding the smallest age. But in this case, we're just looking only at the values where that smallest age is greater than 25. You could remove this. You don't need to have this up here. It'll still run. You just won't get a value with it. But you do need to group by something, I'm pretty sure. Well, you don't need to group by something, but to get anything understandable, you do. So like in this case, yeah, so I guess you do need a group by. Otherwise, you would just be looking at the smallest value and then only returning data that's above it, but you'd also only be returning the smallest value. And so just for understanding's sake, you do need to have a group by before you're having, but there's no reason not to. You can do this with all the math operators. I don't think you might be able to like add columns and see what the values are, but we could also, for example, do like this. And so this would return the minimum age where the maximum age in that country was greater than 25. So like, for example, it doesn't return UK because UK is equal to 25 as their maximum. So you don't need to have the same like min and min. You can do min and max. You can do with any of them. You can do like average or count or something like that. Just more ways to kind of filter and get the specific data that you're looking for. That one's a bit more confusing. Are there any questions about that? Okay. So from here, we get to joins, which is kind of like the fun part of SQL. Joins match data in tables based on conditions, but there's various different types of joins. So I think if you don't type anything, it just does, I want to say, a left join. But you want to be more specific just for people reading your SQL queries and just for you understanding what's happening. So there's inner joins, left joins, right joins, and full outer joins. You can kind of see here, there's many more joins than this. There's like 9 or something like that. But these are kind of the basic ones. An inner join will just grab data that happens in both columns. Wait, I'm going to go. So we want to look at customers and orders. If we were to get rid of all of these and say, so when we join a table, we want to join on values. It's the same idea of you say you joining on and then you give a value equal to another value or a value greater than another value. It's equal. But so then another thing, so for example, if we want to join these two, we're gonna have to use this customer ID. But the customer ID is the same in both columns. And so what we want to do is just add a little C and an O after this, which just renames our tables to that. It's the same idea as doing as. I just always do it this way. I typically just use the first letter of a column. It also helps so you don't have to write out your table name over and over again. But so then we're gonna have to go in here, and we do C dot our columns or C dot all of our columns. And so in this case, if we were to just remove this and run it, all we've done is output all of the columns, but we've done it by renaming this table to something else and then being a bit more specific in which all we mean. which is really helpful when we want to join other tables. So if we weren't to have this and we were to just say customer ID equals customer ID, we're going to get an error saying it's not specific enough and it's ambiguous because it doesn't know which customer ID we're referring to. Realistically, it wouldn't matter in this case. It should be able to figure it out, but it can't. So we do this C dot and O dot and C dot star. And we could also then do O dot star. And if we run this, it'll grab. Okay, we'll run this. And you can see down here, we get a lot of tables or a lot of columns because we're getting a lot of values. And so we're getting everything in this table matched with every matching value in this table. And so you see here that there's 2 4s. That's because in this table, there's 2 4 orders. The ID 4 ordered twice. But also you can also see here that ID 4 never made an order. It's not in this table, but we still get that data. So that would be a left join. For some reason, right joins aren't enabled on this like website yet, which I don't understand how they don't have that. But if we were to just switch these around, we get the same idea if we had it the other way. So this would be a right join in the other way, but now it's still just a left join in this sense. But here we don't get this 5. This column isn't included because it's not in this data set. We could do an inner join, which would just grab the same data that we have here because it's only getting things that are in both. So it's once again only getting 1 through 4. I don't think full outer join is also included, but it would just grab everything in the same way that our initial left join did. So it would still grab this 5 column or the 5 row. Are there any questions on how those kind of joins work? If you search like just SQL joins, there's a lot more out there. But that's pretty specific to once you kind of need to know that. But this is kind of just the basics. Whatever you're joining on needs to be a key of another table. For example, if we were to have like age in here, or if we were to try to link amount to age, nothing would show up because none of these are the same. And you want to like be sure that what you're grabbing is a key, because if you have a big enough table, there's a possibility that an amount of an item could be 22, and then you might accidentally end up getting this row and not really realizing that you've made a mistake, and you could go further and further down into what you're trying to do. And at some point, somebody will tell you that these two aren't keys of each other, amount and age. It's intuitive to us, but when you have 100 columns and they're all named kind of weirdly, it can kind of be confusing. And so you want to really make sure that what you're grabbing is what you should be grabbing. Like just for example, over the summer, I worked with there were like hundreds of tables, and the tables had like 187 columns, and they were all very like specific and very, programmers don't like to give really intuitive names to columns. And so like I a few times accidentally like joined or tried to join tables on columns that like aren't supposed to be related to each other, and you still get values because the data tables have millions of rows, and so odds are some of them are going to add up. But you just have to be careful that what you're doing is what you should be doing. And so if you just have a healthy optimism or healthy skepticism to that data. Just because you get something doesn't necessarily mean that's what you should be getting. Okay. So limit, I'm not going to show this, but it just grabs the like 5 values from that. This once again is very helpful if you're working with large amounts of data, because grabbing a 2 terabyte data will take a very long time and put a lot of like strain on that database management system. And so you just want to limit, if you're initially looking at data that you know is very large, you just want to limit by 5 or limit by 15 to get an idea of what's there. You don't need to look at all 10 billion rows of data to get an idea of what's there. There's other ways of doing this. If you're trying to look at specifics of the data, like top, we'll grab just the top 5. I think fetch first, we'll grab, I don't know, they're all very specific to certain use cases. You don't necessarily need to know those until you do need to know those. if you're looking, like if you're trying to limit, like grab a certain number of values, and you want to get the same results every time, or you want to grab, maybe your table's already like ordered and you want to grab like the first 5 or the last 5, that's when you want to look up kind of what these mean, but they're not super useful unless you need to know them. This isn't the end, but this is kind of a good stopping point of all the basics. So are there any like questions over what I've done? Yes. Good question. I don't really know. Top might look, I don't know. I mean, I guess we can Google it. Help at all. Good question. I think, wait, here, we can see if they have. I know there is a reason, there is an answer. It's just, it's been a little bit. So like limiting to just grabbing the first 2. They might not have support for top. Yeah, they don't have support for top here. Good question. It's a good one to explore on your own free time. Get you like doing this later on so you remember it. Yeah, I apologize. Any other ones? Okay. SQL is like the epitome of easy to learn but hard to master. Everything I've done is pretty intuitive. That is enough for most tasks you'll do. Eventually, though, you will get faced with a question that you need a little bit more to get there, or a little bit finer like filtering or tuning. For example, what if you wanted to like return user IDs from one table, which asked questions in a separate table related to a product in a third table? That's not super intuitive based on what I've just shown you. Or what if you wanted to return, this is actually something I did this summer, is returning like the most frequent questions in a table where those questions contained topics in another table. Once again, not super intuitive based on how it did it. It was a lot more than just that, but that's kind of a simplified version of it. The questions can get very intuitive to ask, but not intuitive to code. Eventually they will, they might not, who knows? But you need a little bit more once you get there. And that's kind of the hard part of SQL is from here, everything, from here, almost everything that you would learn any deeper is going to be very case specific. Certain things like wildcards, which is just a way of saying like, I want to grab a string that contains S and any number of letters after that. Might be a little bit more applicable, but everything past here is very case specific. But if you're ever curious, you just kind of Google how to do this in SQL, and odds are somebody's asked that question before. And if you're faced with very like complicated queries like this, a good way to start is just breaking it down into things you know you can do, and then trying to link those all together. And so like for this first one, you know how to return user IDs from a table. That's pretty easy. From there, you can take those user IDs and you know how to find questions that contain that word. Maybe you don't, but you know how to like find columns that contain a specific word. But combining them all together can be a little bit challenging. One way to do it is temporary tables. This is kind of a good catch-all for complicated queries. It's not perfect though. It's very slow because you're grabbing like one query's results and then you're using that in a separate query, but your computer or whatever like cloud platform you're on can only hold so much data at once. And so if you're grabbing a billion rows from one table and using that to try to filter a billion rows on a separate table, you're gonna run into performance issues. But it is a solution, maybe not the best solution, but I'll kind of show you how to do that. So we'll just restart. So you want to start by wrapping your, so you want to start by just kind of grabbing what you want to do. So for this one, we can try to find the status of orders placed by customers. So we want to return the name of the customer and the status of their, well, the name of the customer, the item they're getting, and the status of their order. So that's kind of a 3-part. You need more than one table. But we want to first start by just grabbing the first and last name of a customer. So we know how to do that. That'll just grab these 2 columns, first and last name. And we know how to join the item that they're grabbing. So we want to then put a C here so we can join more tables. we just do C dot those columns, and then we and so now we have their first, last name, and the item that they ordered. We're getting items that we don't, but we can fix that later. But from here, it's kind of not super like obvious where you want to go. And so we want to wrap this in a table. And so we do, and we do this with blank as. So we're just going to call it like that for data. And then we want to wrap this in parentheses and add a little thing here so it's intuitive where everything is. And so now if we were to just, from here down, if we were to just run select all from that, we would get the same results that we had. No. Okay, so we have the same results that we had, but all we did, we created this query, put it in a temporary table, and then pulled from that temporary table. Do you have any questions about kind of that in particular? You could string two temporary tables together by doing this parenthesis or this comma, and then doing like another name as, and doing the same idea that you had, or same idea as above. And you can do this as many times as you want, and then you can pull from all of those tables. But once again, that's a quick way to get to very slow queries. So we want to kind of do this, but now we want to also join shippings and if we grab this d dot star and s dot status and we run it, so what we're doing is we're taking this temporary table, we're grabbing all of the data from that and then joining another one on that key from that temporary table and outputting something. So now we've joined three tables and printed out a variety of columns from those tables. That didn't work because when we grab this, so one of the mistakes you might make a lot is you forget to add in your key when you're joining on another one, because here you don't need to have this key in here. It'll run without it. But if you want to query it again, you're not querying the data sourced from this, you're querying that data. And so we need to have this in here if we want to join another table on this one. And so we see here, all we've done is outputted all the people, the items that they have, and the status of their delivery. You could expand on this by using like wheres to try to find only people over a certain age, or countries, or so on and so forth. You can add like everything we've talked about up to this point can be put in here. You just don't need to for this case in particular. Are there any questions kind of on what happened here? Yeah. A good takeaway from that is like past here, a lot of database management systems use different flavors of SQL. So like MySQL versus like MS SQL, they're not very different. They'll contain everything here, but certain things further on, they won't be the same. It's very dependent on which one you're using. But you want to make sure that when you're like trying to figure out complicated questions, you want to add in which SQL you're using. I don't know why there's so many. It's kind of a pain to learn, but everyone does little things a little differently, but they all kind of accomplish the same goal in the same way. Yeah. I don't have anything else unless anyone else has anything else. Otherwise, make sure to sign up for Data.io. I'll leave this up here.